section 1. It says, given that f of x, question 1, given that f of x is equal to x squared minus 4 for x is greater than or equal to 0, find the inverse function f inverse, yeah, stating its domain. All right, no problem. That's the question. How do we do inverse? Anybody want to quickly state how you do inverse? So you want to find the inverse of this. So as much as they're giving you these, they know why they give you these. And as soon as you have found the inverse, you're going to see why this was necessary. F of x equal y, because we're not going to write f of x, we're going to write y. All right. And so from this, regular. So step 1, we are supposed to switch x and y. So we switch it. X is equal to y squared minus 4. So we're doing it ordinarily, all right? And then from here, we're transposing. You understand? We want to transpose for the new y. Let me write this better. Want to transpose for the new y. So that means we're going to be adding 4 to both sides, right? So adding 4 to both sides. So what 4 to both sides, as you could see here. So basically we have x plus 4 is equal to y squared. And remember, we're going to take the root of both sides. So we have the root of x plus 4 is equal to y, which means that the inverse of the function is equal to the root of x plus 4. Now you're going to see the importance of that, because in reality, we cannot have a negative number under the square root sign. So you will see why we're going to have to now think of the domain that we can have, don't it? Think about it.
Yes.
Yeah, because you could see now I have 4. If I have negative 4 right here, then I get a 0. All right. So negative 4, I get a 0. But if I have anything like, if I have anything less than the negative 4, I'm in problem. For example, if I replace the x with a negative 5, Abriana, we'll get a negative 1 under here. If I replace it with negative 4 point something, the moment the negative is a bigger numeric value than the 4, we're in problem. So then the domain, when they said pick the domain, you're thinking of, can my function work out where, what could cause a problem? Those are the questions you want to ask. What could cause a problem? So as it relates to the domain of this function, you can see for yourself that x must be greater or equal to negative 4. Because if x is negative 4 and we get the square root of 0, that's fine, because we could get a value from that. But the moment we push it into a negative at this level, we can't find the square root of a negative number. Is that clear? So that's the domain. And as much as it sounds like a big thing, when they ask about a domain, what they want to know is what are the possible x values that we can take and the function works out. The grid provided, sketch the inverse. The inverse, watch this. This is f of x. Look, I want to relate this to you. I might have said it. Inverse of a function actually is a switch of ideas. You hear me? Inverse of a function is a switch of ideas. Where, so if you have a function, the inverse of the function is like the y-intercept of 1 becomes the x-intercept and the x-intercept becomes the y-intercept. It's like things just flip around. But an easier way to look at it is that inverse of a point means the x and the y switch. We can utilize this to get the inverse, because the inverse of a point switch. So if you have an inverse function, then the points will be inverse of each other. For example, this point here is 0, negative 4. The point matching this is going to be negative 4, 0 right here. I want you to understand the point I'm making. the inverse of a function is simply switching of their points all the way. But you see, because this question gives me some nice points, and I understand that the inverse of any function is actually to switch the points. So if I get 4 points, I'm going to flip them and then recreate the new thing. Watch. So the inverse of 0, -4 becomes -4, 0. The inverse of this point here is 1, 3. Abriana, tell me what you think the inverse of it is. 1, -3. What is the inverse?
-3, 1.
Exactly. So it's right here. -3, then 1. Right. Going again. 2, 0. Adrian.
0, 2.
0, 2. Right here. 0, 2. Inverse. And then now, what is this? 3, 3, 5?
Yes, sir.
3, 5. And 3, 5 become what?
5, 3.
3, 5 becomes 5, 3. It's supposed to have flow. Yeah, better vibes. All right, good. See there? So you would have sketched that. Can you see that?
Yes, sir. So the reason for this graph is to ensure that the students understand how to plot the inverse of
a
point.
function. Inverse of a function that you have. And as the teacher, I'm saying the inverse of a function, please remember that you just need to just switch the points, because to get a function, you would plot points. And the inverse of a point is to switch X and Y. So all I have to do is just to switch it and I'm good. And I'm going to show you one other thing now. You ready for it?
Yes, sir.
All right. So switching the point is very important. So you so easily, but the thing is, when you get some clues and you can understand, it's like the thing becomes simple, because you would be here and you probably could stress out over it, only to know that you can just flip the points. But watch this. Watch this now. Look at so it's a teachable moment, so we'll go slow. Look at the x-intercept. The concept of the x-intercept becomes the y-intercept for the inverse. Look at it. The numbers aren't the same, but you could get what I'm saying. For example, the x-intercept, the graph crossed 2 on the x-axis. The inverse of it crossed 2, but on the y-axis. You see my point yet?
Yes, sir.
The inverse, all right, look at the original graph. The y-intercept is -4. And for the inverse, the -4 comes on the x-axis. So it's really flipped, as I was saying. Here, this is the concept. And if you understand that that is the concept, you could just plot back all the points by doing the reverse of it and gone. But I'm just showing you that x-intercept becomes the y-intercept for the inverse, and the y-intercept becomes the x-intercept for the inverse, as long as you understand that, which really means that they are switching, the coordinates are switching fully for every point on the graph. So if they identify 4 points for us, we could flip them to get back a graph quickly. Is that clear?
Yes, sir.
No. State the relationship between, all right. So now they want us to state the relationship between f of x and the inverse. All right. What do you think? Let's look back at it. Well, I'm just going to kick it. If you really look at this here, check this out, then I'm going to show you. Hold on. All right. Yeah. You realize what's going on there? This line is called y equal x. Abriana, come together. You could see that right now, the relationship with these is like the function. The inverse function is a development from a reflection in, it's like, well, it is a reflection in the line y equal x? Tell me if you agree or not.
Yes, sir. Sir, I
Yeah,
learned this
actually.
in transformation geometry. I learned this in transformation geometry.
Yes, yeah. We start transformation at the regular class too, you know. Second class we did on it. All right, so the relationship between that and that. It's a reflection in the line y equal x. The function, so you could write it, or you could state that, listen, f of x to the inverse of f of x is a reflection so you're telling them that, hey, the reflection in y equal x right now as we go. It's a negative. All right, check this out. If they give you stuff like this, these are giveaway questions. Derive the polynomial p of x to the third degree, which has roots 1, 2, and -4. You want to think of, all you want to do is to think. These are the roots. You know, if you get the roots, you know what it means is x equal to 1, x equal to 2, x equal to -4. That's what it means when we say root. Everybody agree to that? Yeah.
Yes.
All right. Yes, so that's the root. So if that's the root, then you can think in reverse and figure out what binomial it came from. And you would have seen that x equals 0. If you think backwards, you would get this. That means when you got the factor, it was x minus 1. And then you said either x minus 1 is 0 or x minus 2 is 0 or x plus 4 is 0. You could see the reverse coming out for the response for these. So you think in reverse. So you could set up these binomials, multiply them, and then get back the original thing. Can you see that?
Yes, sir.
Yeah, man. So I'm going to jump at this one. I'm going to file it out. So I'm going to file that with that, that with that, that with that, that with that. So I'm going to file out x with x, that's x squared. X times -2 is -2x. -1 times x is -x. -1 times -2 is +2. Good?
Yes, sir.
So basically what we have out of this is -x minus 3x plus 2, and that's for that. And definitely no, that will be multiplied by x plus 4. Agree? Yeah?
Yes, sir.
All right. Remember now, so we don't need this 0 there now. Remember now, we're saying that it's actually, what is it we did? P of x is this. Let me fix it better. Let me just get the thing. Hold on. Give me a second with this. All right, good. We're saying is P of x equal to that. So all of this is what we're saying. This is P of x. So we're going to file again. Remember how file go? Simple vibes. This go with not, then it go with that, then this go with that, it go with that, and then let me change the marker for this one. And the -2 go with that, and then you go with that. So basically it's the same principle, everything go with everything. So let's just take our time and we do it, all right? So basically the polynomial will be P of x is gonna equal to x squared times x, I'm getting x to the third degree. X squared times 4, I'm getting positive 4x squared. Then -3x times x, I'm getting -3x squared. -3x times 4, I'm getting -12x. The green. 2 times x is positive 2x. 2 times 4 is positive 8. And all we have to do is to simplify this now in the end to get back these values. So I don't have any third power, so I would have x to the third power there. to the second power, I'll just say 4x squared minus 3x squared, I have positive x squared. And I'm looking at negative 10x and a positive 8. All right, you could ask question now. So this is what they ask here. Derive the polynomial p of x of degree 3, which has roots equal to 1, 2, -4. So you could see how you just relax, think about how you would have gotten the roots, think backwards, and then you expand your thing, and here you are with your polynomial.